Fill a cup with an ordinary liquid and it stays put. It sits at the bottom, held down by gravity, waiting for you. That is the one thing every liquid you have ever handled has in common. It stays where you pour it. Now imagine a liquid that doesn't. You pour it into an open cup, and it quietly climbs the inside wall, flows up and over the rim, runs down the outside, and drips onto the table until the cup is empty. Nobody tipped it. Nothing pushed it. The liquid simply left, crawling out against gravity as if the cup could not hold it. That liquid is real. It's helium, cooled to within about 2 degrees of absolute zero, the coldest it is possible for anything to be. And escaping a cup is the least strange thing it does. Let me show you a liquid that breaks the rules you didn't know were rules. Helium is the second lightest element, and it does not want to be a liquid at all. You have to chill it to about 4 degrees above absolute zero just to condense it into one. But the real magic happens a little colder, at a temperature physicists call the lambda point, about 2.17 degrees above absolute zero. Watch liquid helium as you cool it toward that point, and you'll see it boiling furiously, bubbling like water in a pot. Then the instant it crosses the lambda point, the bubbling stops. Not slowly, all at once. The surface goes flat, glassy, and dead still. It hasn't stopped being cold. Something more unsettling has happened. The liquid has become so perfect a conductor of heat that it cannot hold a hot spot long enough to form a single bubble. Any warmth dumped in anywhere is whisked across the entire volume instantly. The helium has become a superfluid, and it now conducts heat better than any metal, flows with zero friction, and obeys the laws of the very small at a size you could almost hold in your hand. Zero friction is the key to everything that follows, and it is not an exaggeration. A normal liquid dragging along a wall loses energy to it. That's viscosity, the internal stickiness that makes honey pour slowly. A superfluid has, for part of itself, exactly none. It can flow through a channel and lose nothing. So consider what happens at the wall of the cup. Every surface touching the helium gets coated with an incredibly thin film, only about 30 billionths of a meter thick. In any normal liquid, that film would just sit there, pinned by friction. But this film has no friction to pin it, and since the helium can lower its energy by spreading out, the film simply flows. Up the inside wall, over the lip, and down the outside, a silent, invisible current draining the cup, one atomic layer at a time. Leave an open container of superfluid helium sitting still, and it will empty itself onto whatever is below. This is called the Rollin film, and there is no way to pour a liquid that refuses to stay poured. The same zero friction lets it do something else no liquid should. Give it a crack, a pour, a gap so microscopically fine that ordinary liquid helium, already one of the runniest substances known, is completely blocked. The superfluid slips straight through because there is no friction to hold it back. Physicists call such a gap a superleak, and it is nearly impossible to build a container that a superfluid cannot find its way out of. Here is where it stops being merely slippery and starts being alien. Take a small chamber of superfluid helium connected to the outside by a thin nozzle and gently warm the inside. A tiny heater, even a beam of light on some packed powder. In any normal fluid, heating makes it expand and drift lazily. In a superfluid, the frictionless part rushes toward the heat. It pours in so eagerly that it builds up pressure and sprays straight up out of the nozzle in a continuous standing fountain. A jet of liquid driven by nothing but a whisper of warmth. Think about how backward that is. You add heat to one spot, and a fountain erupts somewhere else and keeps erupting for as long as you keep the heater on. Warmth in this liquid is a pump. There is no moving part, no pressure line, just the strange fact that in a superfluid, heat and flow are tangled together in a way they never are in the world you live in. And then there's rotation. Take a bucket of ordinary water and spin it, and the water spins with it, its surface curving into a smooth bowl. Try that with a superfluid, and at first, nothing. Spin the container slowly, and the liquid inside just sits there, motionless, ignoring the walls dragging past it. It flatly refuses to rotate. Push the spin faster, and it doesn't give in gracefully. Instead, the rotation appears all at once, in fixed, indivisible packets, tiny whirlpools called quantized vortices, each carrying exactly the same, precisely determined amount of spin, never a fraction more or less. Spin harder, and you don't get a faster swirl. You get more of these identical little tornadoes, arranging themselves into a neat lattice. A superfluid cannot rotate by any old amount. It can only rotate in whole numbers. That word, quantized, is the tell. This is the same rule that governs electrons in an atom, where energy comes only in fixed steps. Here it's governing a visible pool of liquid. Because that's the secret of the whole thing. Down at the scale of single atoms, quantum mechanics lets particles share one identical state, described by a single wave that spans them all. Normally, that behavior is locked away in the invisible world of the very small, drowned out the moment you gather enough atoms to see. Helium, near absolute zero, is the loophole. A huge fraction of its atoms drop into one and the same quantum state and start moving in perfect lockstep. And suddenly the weird arithmetic of the atom is written large enough to pour, to watch, to film. The climbing film, the fountain, the whirlpools that come only in whole numbers, those aren't tricks. They're what a single quantum wave function looks like when it's the size of a teacup. You will never meet this liquid at home. It exists only in the deep cold of a physics lab, a couple of degrees from the coldest anything can be. But it's a rare, honest glimpse of the machinery underneath everything. The quantum rules that are always there, usually hidden, running the world one silent layer beneath the one you can touch. That's the fine print on the coldest liquid in the universe. And reading it is exactly what this channel is for.